Good evening, guys. I hope you guys are good and are doing so well. It's another day, another dollar. If it's your first time, do us a favor, add yourself a favor, and make sure that you hit that subscribe button so that you can be able to see when we are live. And also in the description of this video, join our WhatsApp group so that you can be able to ask us questions anytime, anywhere, and in real time, so that everything will go well. So today we are doing our preparation for the trial exam. So we're gonna look at trigonometry first. In the group, people are asking for trigonometry, so we're gonna start with trigonometry today. Then on Wednesday we're gonna have Euclidean geometry. Then another day on Friday, hopefully we'll be able to have our analytical geometry, so that we can be able to be fully equipped on our paper 2, because we know that on paper 2 we have 20 marks statistics. We covered it on the previous control test. We have 40 marks analytical geometry. We have 40 marks for trigonometry, of course. And the last one, which is the masterpiece, which is Euclidean geometry, which is always like 50 marks. So today we want to see if we can be able to cover our trigonometry from this preparatory exam, which was written last year in the Gauteng province. All right, so as you can see from my screen, this is from Gauteng province, and we will try to do the trigonometry of this province so that everyone can understand how we solve problem. If you need more understanding in the basic stuff, I'm gonna also put a thumbnail here so that you can be able to go and check those videos where we start by explaining everything from grade 10, when we are looking at our trig ratios, when we are looking at our reduction formula and everything which we covered already. So we won't be covering that now. We'll just go through the questions, and after that we explain further on the questions which we have. Boom. In the diagram below, question 5. Let's write question 5 over there. Now we're solving question 5. In the diagram below, P is the point 12:5, as you can see where P is, which is in the first quadrant, as you can see, and we have T, which is A is to B in the second quadrant, and we are told that OT is perpendicular to OP. That's interesting. Even you can see even the 90 degrees there. So we know something about perpendicular lines, that their gradients, when you multiply them, they should give you -1. So by knowing that already like highlighting the things as you are reading the statement. And now PS is perpendicular to the x-axis. We can see that 90 degrees, making the triangle OPS a right-angled triangle. So by that already we know that we can apply our Pythagoras theorem, because we know that that's a right-angled triangle over there. So from that point also, we are also told that POS is the angle theta, as you can see over there. Now without using your calculator, so don't use your calculator, because if you use your calculator, as when we are marking at the exam center, we know that you have used the calculator. Determine the value of tan theta, which is 5.3.1. Let's do that now. So we know that we are given our triangle, which is in the first quadrant, and it's given with letter P, which has a coordinate of 12:5. So we know that a coordinate P is x is to y. So in this instance, P is 12:5. So in other words, you are saying that it is 12 units on the x-axis, and it's 12 units from the x-axis, and it's 5 units on the y-axis. So we need to know what is the value of r, and of course we know again we are given point T, which is A is to B. So now we can be able to calculate the value of r according to the Pythagoras theorem before we even solve the problem which we have at hand. So we know that r squared is always equal to x squared plus y squared. What is our x squared? Our x is 12 units, so that's 12 squared plus 5 squared over there. Then after that we use our calculator, which is a Casio calculator. I can't see mine here right now, but we use our Casio calculator so that we can get our proper answer. 12 squared, then of course you have our r, then we square both sides, then now of course we finally have our r, which is the hypotenuse side. Using your calculator, your r will be equal to 13. Okay, then now let's solve the question. 5.3.1. what is tan theta? We know that tan theta is always equal to opposite over adjacent. So again we come back to our triangle which we are having here, which is triangle O, P and S. Okay, so we can now be able to find this tan theta. We know that tan theta is opposite over adjacent, so our answer there will be equal to 5/12. That's basic stuff. I'm sure everyone knows that. Now we go to 5.1.2. now we need to find sine of theta. Since we have already calculated this, we know that sine theta is always opposite over hypotenuse, and we know that our hypotenuse is 13 and our opposite side in this instance is 5. So our answer will be 5/12. Then this will be, oh my word, what's happening here? That will be 5/13 over there. So we are cruising nicely, because this just is basic stuff. So now they are telling that if without choosing a calculator, saying that A, if TO, determine the value of A, okay, if TO is equal to 19,5 units. So we are given the length of TO, or they are saying that now we're on 5.1.3. 5.1.3, we are given that TO's length is equal to 19,5 units. Now they say that, okay, now that you know that TO is 19,5 units, now what will be the value of A which you have over there? So with that being said, and with us knowing that, okay, this is just basic stuff, this is easy stuff, I'm sure everyone enjoys when we do maths, and we know that, okay, when we look into this properly, let's use a different color over there. So this is our TO. So we can see that they're saying that TO, which means this length of this part to this part, which is R, is equal to TO, which is equal to 19,5. Now they are saying what is A. We know that this is a coordinate. A is to B, and since A is to B, which means our A is representing X and B is representing Y, so that will be B over there and that will be A over there. So since we know the R, what is the relationship between A and R? We know that the relationship between those two is we are looking at the perspective of using the coordinate, which is cos of theta. So we know that cos of theta, or that cos there, will be giving us the proper answer there. But you can see that it's in the second quadrant, which is 90 plus. So let's write that down first. So that therefore we know that cos of 90 degrees plus theta will always be equal to A over the 19,5, because it's in the second quadrant. Okay, then after that we know that in the second quadrant, cos, it's a co-ratio, so 90 plus is in the second quadrant and cos is negative, which means the co-ratio of sine will always of cos will be positive sine theta, which is equal to A over 19,5. Okay, now that we have this answer, we know that sine theta, we have calculated sine theta, and sine theta we found that, okay, sine theta is always equal to, where are you? Here it is, which is equal to 5 over 13. So now we have negative 5 over 13, which is equal to A over 19,5. Then of course now we can cross multiply so that we can make A the subject of the formula. Then A now will be equal to 19,5 times negative 5, which we have over there. Then we divide that by 13. Then again we'll use our calculator so that you can get the answer over there. Okay, so when you are getting the answer over there, that will be what? Using your calculator or using mine, I am getting negative 7,5 units. So that will be the value of A. So my A is equal to negative 7,5 units. And it really makes sense. Why is it making sense? We can see that we are having a negative answer, and even on the quadrants which we have here, we can see that this is the second quadrant, and on the second quadrant we know that is always 90 plus and 180 degrees minus. So cos in this second quadrant is always negative. So we can see also that our A value in this quadrant, that's the X, the negative X coordinate, or next negative X axis. So in the negative X axis, our A value definitely supposed to be negative here, and it's only the Y value, which is B, which is going to be positive. So maybe this year they'll say calculate the value of B. So how do you calculate the value of B? You know that the value of B, you can calculate it by saying B over R, which is the length of TO, which should be equal to, of course, maybe your sine of theta, or sine 90 plus theta, because you can see that it's in the second quadrant, and we know that in the second quadrant is 90 plus. Then we use our reduction formula, then boom, you get your 4 marks. Easy stuff, proper stuff where anyone can be able to solve anytime they want to solve the question. Now moving forward to the next question now, which is 5.2. Sorry about that, someone is calling. 5.2, back to red. I love red, I hate blue. Now let's go back to red. 5.2. So now on 5.2 we are sold. Okay, determine, let's enlarge our screen so that everyone can see what's just happening now. So on 5.2, determine the value of the following without using a calculator again. So please don't use your calculator to solve problems. Okay, so now they are giving us sine of 360 degrees minus 2x times sine of negative x divided by sine of 90 degrees plus x plus 2 cos squared of 180 degrees plus x. Now we can see that this is where we need to apply our reduction formula. So we know these things, guys, and we know that we need to use our triangle, which we have always, or our reduction formula, which we're having here. So we know that this is 90 plus, this is 90 plus, this is 180 minus, this is 180 plus, that will be 360 degrees minus, that will be 360 degrees plus. And we know that all students take coffee. Okay, so all, which means all the trig ratios in the first quadrant are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. Now let's reduce this thing. Sine of 360 degrees minus, so we come to the angle 360 minus. 360 degrees minus is in the fourth quadrant, and is sine positive or negative? It's negative. So that's the first reduction there. So that will be equal to negative sine of 2x. Again, we go back, then we have sine of a negative angle. We know that sine of a negative angle is always equal to negative sine, always, because every angle which is negative, when we are using sine, it's going to be negative. Of course, we divide by sine 90 plus. Again, 90 plus is in the second quadrant, and sine is positive, but we know that sine has a co-ratio which is cos. So since now we know that it's positive in the second quadrant, which means the co-ratio also is going to be positive. So now we're going to have cos of x here, then plus, of course, 2. Now we have our cos squared of 180 plus. So we know that cos of 180 plus, this will be the same as cos of 180 degrees plus x. Then of course we can square all of this. Okay, then we know that 180 plus, let's do this next time, which is equal to negative times negative, that's positive. So now we are left with next sine 2x times sine of x divided by cos of x plus 2. Then we know that cos of 180 plus, 180 plus is in the third quadrant, and in the third quadrant it's only tan which is positive, so our cos is going to be negative. But we know that cos of x now is negative. When we square this, is just going to give us a positive cos, so that's why we end up having cos x squared, which is positive. So cos squared of x, which is positive. Now we know something which is nice and easy, that sine 2x is a double angle, and since it's a double angle, we know that that's the same as 2 sine of x times cos of x times now that sine of x which we have here divided by cos of x plus 2 cos squared of x. This and this will cancel. Sine x and sine x will multiply each other. That will be 2 sine squared of x plus 2 cos squared of x. Then of course, because we are smart, we can take 2 to be our common factor out. Then that will be sine squared of x plus cos squared of x over there. Then we know that sine squared of x plus cos of squared of x is always equal to 1. Then we have 2 times 1. Then our final answer will be equal to 2. The beauty of trigonometry, let's go in the exam, let's go and get those full marks, because if we don't get them, who is going to get them for us? So that's how we solve that without using our calculator. We're just playing around with the reduction formula and the reduction formula which we are given over there. Now proceeding now to the next question, they're saying that given cos 42 is equal to root k, without using a calculator, determine the value of sine squared of 69 in terms of k. This is interesting. This is amazing. So we are told that this is 5.3. I get excited when it comes to math, guys. I apologize for that. So we know that we are given cos of 42 degrees, which is equal to root of k. So something which is just something which we have never been asked before we even look at the question, that what is sine squared of 69 degrees. So there's something which is beautiful about understanding this terminology and how trigonometry plays around. If we plot this in the first quadrant, we have our 42 degrees there, we have our 90, that will be 42 degrees, and that will mean that if it's equal to root k, which means it's root k, and our hypotenuse is always equal to 1 over there. So now after that point, we know that 90 plus 42, 90 plus 42 will be equal to 2, then that will be 10, 13, 132, then 180 minus 132 over there, that will be 8, that will be 4, that will be 48 degrees. So this will be 48 degrees there on that angle. It's just us plotting, and we know that this part here, we can calculate this y value when we want to calculate. Let me remove that big screen so that everyone can see. Here we go. So now we are given cos 42 degrees. So we know something about 42 degrees. And now our question is, we need to calculate the value of sine squared of 69 degrees in terms of k. How do we relate to 69 degrees in terms of k? This is, again, this is an easy stuff, because we know that cos 42 is a double angle. So we know that cos 42 degrees, if we take it as a double angle, that will be equal to 2 cos squared of 21 degrees over there, okay, minus 1. Okay, then from that point now we know how to navigate our round. We know that cos 42 is root k, which is equal to, now we have 2 cos squared of 21 degrees, which is the same as 2 sine squared of 69 degrees minus 1. That's just easy as that, and straightforward as that, as we are breaking down the question which we are having. Then of course that will be now a root k plus 1, which is equal to 2 sine squared of 69. Then the question wanted us to have solve sine squared of 69. So we divide both sides by 2, we divide both sides by 2, this and that. Then therefore we can conclude that our sine squared of 69 degrees is equal to root k plus 1 over 2. So that will be our answer. I enjoy doing maths. I enjoy it. Please practice so that you can be able to enjoy as I am enjoying. Now let's look at 5.4. Given the identity, oh my word, identities. Easy stuff because we can be able to play around with what we know, compound angles, and we can solve the problem. Sine 5x times cos 3x minus cos 5x times sine of 3x. Sine cos cosine. Sine cos cosine. That's already a compound angle. We all know that. Sine cos cosine. Sine cos cosine. That's a compound angle, so we can be able to solve the problem without even wasting much time. So now they said prove the identity that the left hand side is equal to the right hand side. So let's break down the left hand side. And how do we do that? We start by saying the left hand side is always equal to. Then now we copy whatever we have. We have sine of 5x times cos of 3x minus cos of 5x times sine of 3x. Then of course we divide all through by tan of 2x. That's the first step because we want to break this left hand side because it's too complex and there's a lot of things which we can play around when we are looking at the second side. So now we can see that this is sine cos cosine, sine cos cosine. So this is us now knowing that, oh man, no man, we have what we call compound angles. So since we have compound angles, we know that sine of A minus B is the same as sine times cos minus cos times sine. So this is what we have. So this is the same as sine of 5x minus 3x all divided by tan of 2x. Interesting. That's why I love maths. So that will be sine of 2x divided by tan of 2x. This is great. Oh my word. Before we can see that sine 2x is a double angle, but there's something also we know about tan 2x, that tan 2x is an angle, it's an identity which we taught in grade 11, that tan of theta is always equal to sine theta over cos theta. So let's try to exercise our right. So this can be written as sine of 2x times tan of divided by tan of 2x. So what is tan 2x? This will be equal to sine of 2x divided by, our tan will be now sine of 2x divided by cos of 2x. I love maths. This will be equal to sine of 2x multiplied now, because now we are dividing, so that will give us a reciprocal, times cos of 2x all divided by sine of 2x. Then of course this and this is kind of sabana, they cancel each other. Then now we are left with only cos of 2x on the left hand side. But they say that prove that the identity is equal to oh my word, I just did something which is not good. I forgot this negative. Why did you guys tell me? Okay, we have -1 here, guys. Oh my word, I'm so sorry. So now everything now is going to change, but not really. It's just gonna add our -1. Why didn't you guys tell me that? Then we have again bracket -1, put a bracket over there, -1. Then after we solve that, that's -1, so that's just going to be -1 there. Okay guys, I'm so sorry guys, I'm so sorry because I literally forgot about that. But now we know that cos 2x is a double angle. So since the double angle, can convert that to be in terms of sine. So we know that the double angle of cos 2x can be equal to cos 2x, or cos 2x can be equal to 2 cos squared of x minus 1. It can also be equal to 1 minus 2 sine squared of x. It can also be equal to cos squared of x minus sine squared of x. Okay, these are just all the double angles of cos 2x. But now we can see that our question, we are given something which has to do with sine. So let's choose the second one. So that will be equal to 1 minus 2 sine squared of x, of course, minus 1. This will be 1 minus 2 sine squared of x minus 1. Then 1 minus 1 is equal to 0. Then we have -2 sine squared of x, which is equal to the right hand side. Yes, here we go. So that's how we solve the problem. We are playing around with what we are given. We are playing around with the compound identities which have been taught in in grade 12 first term. We are playing around with what we know. We know this. So we just have to know that sine cos cosine, we know that that's an identity. And of course, we know that our tan 2x there, that's our identity which has been taught from grade 12. And that says that cos sine theta over cos theta. Then from that point, we can be able to get the answer which we always want. So with that being said, we can say and we can be able to prove that it is equal to our right hand side. Now let's look at 5.4.2. Now determine the values of x for which the identity will be undefined in the interval for x is an element from 0 to 60 degrees. Oh my word, this is easy because we can see that we have the denominator, so the function is always not determined at the denominator. So this is 5.4.2. So this is easy stuff because we know that this will not be, let's write that English so that everyone can understand. So this function which we are having, or this trigonometry or identity which we are given, it's undefined if our tan 2x is equal to 0. If that is equal to 0, when you divide that with the calculator, anything divided by 0 is undefined. It's literally undefined. So now we can be able to solve. This is now easy stuff because we know that tan of 2x is equal to 0. So now we can solve this, guys. I mean, we can solve this so that we can get an answer. So tan of 0 there, that will give us 2x, which is equal to our 90 degrees. Then from that part, we know that we can solve for x divided by 2, then our x is equal to 45 degrees. So we can see that the value of x is equal to 40 degrees, and also at x is equal to 0 degrees, guys, when x is equal to 0 again. So these are the two values of x which are in the interval. X is the element of 0 to 60 degrees over there, so they won't be defined in those two terms, guys. So otherwise, you could have just said, of course, it's undivided and tan 2x is equal to 0. Then try to plot the function using your calculator so that you can get the coordinates in which it's going to give you an undefined stuff so that you can have the proper answer. Now, let's look at 5.5. I love maths. Given f of x is equal to 2 cos x minus sine squared of x. Okay, right. So what do you want us to do? Let's check that out. So in this 5.5.1, we are initially on 5.5, we're given f of x, which is always equal to 2 cos x minus sine squared of x. Okay, that's interesting. But now, what do you want from us? That's the question. That's the $1,000,000 question we need to ask. What do you want from us? They're saying that show that f of x can be expressed as f of x is equal to cos x plus 1 squared minus 2. Guys, this is so much fun. So now we can see that we need to change everything to be in the terms of cos, and we know that we are given sine 2x, and we know something about sine 2x, that we know that cos squared of x plus sine squared of x is always equal to 1. So when we make sine squared of x to be the subject of the formula, that will be 1 minus cos squared of x. Yes! That's an identity from grade 11. So we're applying that identity which you have been taught in grade 11. So moving forward from that point, now we can see that this will be now equal to 2 cos of x minus, then of course that part we replace with 1 minus cos squared of x over there. Now this will be equal to 2 cos of x minus 1 plus cos squared of x, which is the same as cos squared of x plus 2 cos of x minus 1. Then now we can see that this is just a normal quadratic equation which we can solve then. So when we solve this is going to be easy for you because I mean this is already straightforward. So we can see that we can have this answer, and we can see that this will be the same as what? Cos squared of x plus 2 cos of x plus 1, of course, minus 1 minus 1. We can still see that we can still get 1. 1 minus 1 is equal to 0. Then still remain with that negative which we have there. Then we can solve that. This will be cos of x plus 1 all squared minus 2. Hey, maths is fun. If your friend doesn't love maths, please make sure that you just tell them, like, you know what, our friendship is over, because maths it's nice. You can never go wrong with maths. Now let's look at 5.5.2. Now hence or otherwise, which means whatever you have solved from above, now use it and find the maximum value of f. So how do you find the maximum value, guys? This is easy because we know that we are having our cos of, so let's just say maximum maximum at, or maximum of cos x equal to 1. So we know that it will be max when we can have our cos of x plus 1 all squared is 1 plus 1 all squared, which is just equal to 4, because 1 plus 1 is equal to 2. Then that is going to be equal to 4. But in our instance now, we know that we are given cos of x plus 1, as we have solved there, squared minus 2 which is equal to 2. So that will be our answer there. So the maximum is to understand that we have a maximum at cos x is equal to 1, and now breaking it down, 1 plus 1, then we get squared there, then we get the 4 over there, so that we can get the answer which we finally want. So if you resolve or resolve this question and going back to what we had initially, have what the values which we initially had, then of course after that you get your 26 marks. Smart people, I guess. Now let's look at question 6. Last question on trigonometry. Given the equation cos of x minus 30 degrees plus 2 sine of x is equal to 0, show that the equation can be written as tan x is equal to negative root 3 over 5. Okay, that's 4 marks. That's hectic over there. Why would they do that? But I mean, like me and you guys, we know this, that these guys just want to play with our lives. So I mean, we are not scared of anything. We are not scared about anything. So if you're not scared about anything, let's solve these questions. Let me try to maximize the screen so that you can see this question properly. So on that question, we are given that cos of x minus 30 degrees plus 2 sine x is equal to 0. So from that point, I mean, guys, we can be able to show what they want us to show there. So let's minimize the screen. Let's play around this. So we know that this can be an identity, which is cos of x times cos of 30 degrees plus sine of x times sine of then this is just a common angle because we want to show what they want us to show. So we are not jealous. We know how to solve this because we have been taught common angles. If you want more clarity on common angles, please go down on the videos of Yebo Tutor. See me explaining everything from compound angles, breaking them down and proving everything for you over the plus 2 sine of x is equal to 0. So we know that this will be the same as or cos 30 degrees without using a calculator again, or you can use a calculator. Actually, we know that this is straightforward. That would be root 3 over what? Let me check. That'll be 1, 2, 3. Yeah, that will be root 3 over 2 cos of x plus, of course, sine of 30. Now that's 1 over 2 sine of x plus our 2 sine of x is equal to 0. Then of course, because I'm a good person today, I know that if we multiply all through by 2 so that we can only remove the denominator there, that will be root 3 cos of x plus sine of x plus, now 2 times that 2, that will be 4 sine of x is equal to 0. Then that should be root 3 cos of x plus 5 sine of x, which is equal to 0 because sine x plus 4 sine x is equal to 5. Then that would be what? 5 sine of x is equal to negative root 3 cos of x. All right, then if we divide, okay, this is not nice, this is not interesting. I love interesting stuff, guys. So if we divide this side by cos of x, both sides by cos of x, then now we'll be having sine x minus that will be 5 times tan of x equal to negative root 3. We divide by 5 both sides, then we are therefore having our tan of x, which is equal to negative root 3 over 5. Wow, guys. Oh, is this true? Let's check that first. Let's check it first. Oh my word, I'm so excited. Okay, so we can see that tan x is equal to negative root 3 over 5. Let me recap that so that everyone can be on the same par with me. So we see that on this part here, we try to erase this 2. And how do we do that? We multiply it all through by 2, this also multiply by 2, this also multiply by 2, this also multiply by 2. So this 2 and 2 cancel, this 2 and 2 cancel, then 2 we multiply by 2 as well here. That will be 2 times 2. That's why we have the 4 here. And after that, we can see that sine plus 4, that's 5 sine x. Then of course we can solve our problem. Oh, guys, let's solve maths, guys. There's no way we're gonna fail maths this year because Yebo Tutor is here for you. If you're tuning in right now, do yourself a favor and subscribe to this channel and share your comments and join our WhatsApp group so that we can be able to engage as much as we can. Now let's move on to 6.2. Let's go back to red. I love red. You love red. If you love red, type on the group on the comment over there. 6.2. Determine the solution of the equation cos x minus 30 plus 2 sine of x equal to 0 in the interval of negative 180 to positive 180. Guys, this is so easy. We have already solved that part, and we saw that tan of x is equal to negative root 3 over 5. Sort of like a general solution, guys. So we can be able to solve this problem quick, fast. Okay, I'm sure everyone can do that. We know that this is for tan, so that would be the arctan of negative root 3 over 5 plus, of course, 180 degrees of k, where k is the element of integers over there. Then we calculate there using our calculator. I'm getting our 160 degrees over there, or comma 89 degrees. What is it? That's just a big angle over there. So, but when you use that calculator, I'm getting two angles. I'm getting my reflex angle, which is 19, comma 11. Let me see. Negative 19, comma 1 plus 180 degrees of k, where k is the element of integers, and this is a reflex angle, which can also be 160 degrees, comma 89 plus 180 degrees of k, where k is the element of integers. That's easy stuff there. So the values, which one is x is equal to negative 19,11 degrees, and x is equal to 160 degrees, comma 889. This is just the smaller angle. Then when we are now looking at 180 degrees minus that x value, we'll be able to get the correct answer. Oh my word, I apologize for that. Here we go. So we see that this is just a tan of x. So we can look for the general solution. You know that the general solution of a tan of x will be uptan of x plus 180 degrees of k, where k is the element of integers over there. Then after that, you can get the answer. It's a weekend. It's a Sunday. I hope you guys went to church. All right. So these answers which we got, we can see that they are also in the interval of negative 180 degrees less than x less or equal to 180 degrees, which is positive. Now let's look at 6.3 now. On 6.3, let's maximize the screen. Please don't. Hopefully I won't forget. In the diagram below, the graph of f of x is equal to negative 2 sine x is drawn for x is the element of negative 150 to 210 degrees. Okay, so write down the amplitude of f. Guys, come on. That's 6.3.1 over there. Guys, that's easy stuff. We can be able to write down the amplitude. So we can see that the maximum point, the graph is going from 0 going up. It's at 0 to 2. So we can see that our amplitude there is just going to be equal to 2. That's easy stuff. I didn't have to write that. Draw the graph of g of x cos x minus 30 for the interval of x, so that on the grid provided in the answer book. Easy stuff. Easy stuff. Why is it easy? Because we know that 6.3.1 or 6.3.1, this will be 6.3.2. So when we are plotting a function, guys, this is always the same case. Let me just show you now. So when you plot the function, the first thing is to be able to understand that you are given g of x, which is equal to cos of x minus 30, and also they've given you an interval which is negative 150 to 210. So now we can just use the interval which we have over there. Then we plot our function negative 150. Then maybe we can use 90. Let's use 30 there. So negative 150. Then of course we're gonna have here it's gonna be 0, 30, 60, 90. 90, 120, 150. 180 to 10. So this would be negative 30, negative 16, negative 19, negative 120, negative 150. So this will be the corners. Then after that, we use our calculators. So when we use our calculators, we just press this thing. We say a mod. Then after that, you choose graph number 2. Then you put our function over there. Then of course, they will ask you it's starting where. It's starting from negative 150. Where is it ending? It's ending at 220. What is our step? Our step in this instance, you can see it's 30. The difference between 2 points is 30 degrees, 30 degrees. So after that, you can just elaborate and substitute there with 30 degrees. Now that will be that will be easy, and you can be able to plot a function. Then there's two questions, 6.3.3. Now you need to analyze the functions. Guys, where g of x will be greater than f of x. That's just you now seeing on the functions which you have plotted, so that you can get the value. So that won't be really hard on your side. So this is what I had prepared for you guys. So try to do, it's your homework. It's your homework. Try to do 6.3.2 and 6.3.3, then post on our WhatsApp group. There might be something over there. You never know. So do us a favor and make sure that you do that for yourself and ourselves. From Buyani to you all. Let's see each other next time. This coming week when you're looking at Euclidean geometry. Stay put. Practice more questions. Join our WhatsApp group so that you can interact with you. If you have any question, anytime, ask us questions on the group so that we can be able to interact. Even on the chat box here on YouTube, just ask us your questions so that we can be able to entertain and we can be able to engage with you guys. Till we meet again.